Hi, I'm Kavya, and I looked at how surface tip affects tennis ball bounce height. So, for motivation and context, personally, this connects to my own experience in tennis. I played for years, and some courts always felt super lively and others felt dead, and that changes how the game plays. From a physics perspective, this comes down to how much energy each surface returns. Ultimately, I learned that hard surfaces give you higher bounces and soft ones absorb energy. And socially, the surface you have access to can shape how consistent or safe your play experiences in your community. So my prediction was pretty simple. Hardwood would give the highest bounce, carpet would give the lowest, and the blanket on hardwood would fall somewhere in between. For the background, the physics idea behind this is energy conservation. When you drop the ball, it has gravitational potential energy, or MGH. As it falls, that becomes kinetic energy, and the bounce depends on how much energy is returned. Elasticity also matters. Harder surfaces deform less, so they return more energy. And then this is tied to the coefficient of restitution. A higher COR means a more elastic collision and a higher rebound. So, for social context, these surfaces also represent real world spaces. Carpet is like a soft indoor surface that kids often play on. Hardwoods are like gym or indoor courts where bounces are really consistent. And then, lastly, hardwood with a blanket is like improvised play basements or community spaces where people put padding down. All of these influence how people experience sports depending on the spaces that they can access. So, for the experiment, I kept the drop height constant using a meter stick and used the same tennis ball for every trial. I tested three surfaces: hardwood, blanket on hardwood, and carpet. I recorded each drop on my iPhone, imported the videos into Tracker, and then used it to find the peak rebound height. So here's the system schema showing the interaction between the ball, gravity, and the surface. The key energy transformations are potential energy. Right just after it's dropped, and then it becomes potential energy and kinetic energy midway, and then it falls back down to just kinetic energy right before it hits the ground. So here's the data. And for carpet, I found that the peak rebound height was 0.492 meters. For hardwood and blanket, it was 0.466 meters. And then for just hardwood, it was 0.666 meters. So hardwood gave the highest bounce, blanket the lowest, and then carpet was slightly above blanket. For analysis, my prediction was mostly correct. The hardwood was above the carpet, which was above the blanket. The only small surprise was that carpet bounced slightly higher than the blanket, but the difference was very small, just a few centimeters, so it's likely within the measure of uncertainty. For interpreting the data, overall, the trend supports the physics. Harder surfaces are more elastic and lose less energy. The small inconsistency probably comes from things like slight camera angle differences, scaling in Tracker, or the exact point on the ball being tracked. These small variations can shift the bounce height by several centimeters. For other research, I compared my experiment to a study by Colombo, which measured the coefficient of restitution for balls on different surfaces, including fabric over hard floors. They found that adding a fabric layer reduced energy return, which is similar to my blanket on the hardwood results. Their methods were more precise, using forced plates and more trials, but the core idea matches what I observed. This matters because even small changes to flooring, like mats or blankets, can affect how balls bounce in gyms and community spaces. My claim is that hard surfaces return more energy and produce higher bounces. The evidence is both the physics theory and my measured rebound heights. The reasoning is that rebound height directly reflects the energy the ball keeps after impact, and soft surfaces absorb more of that energy. Some sources of error include calibration differences between videos, human error in tracking, slight angle differences. These could all shift bounce heights by a few centimeters, which explains the small difference between carpet and blanket. Overall, this project helped me connect physics concepts to something I experienced in real life. I learned how sensitive video tracking can be and how different surfaces really do change how sports feel. It strengthened my scientific reasoning and helped me understand a familiar activity on a much deeper level.
And here's my class problem, the solution, and my sources.